these programs actually have some kind of thinking. Give a try on all this kind of logics with nested loops. Okay, you can apply even nested for also. You can, if you need some help in some cases, you can Google it and try to because that is also very important. Now I am jumping to the data structures. Just show you some useful stuff for you. I'll share that blog also where you have plenty of problems with solutions, but you can go through problems only. Structures, data structures. We just had a quick introduction yesterday, but that would be, that is not sufficient for us. And then data structures, or what we can say is a collection. So what we say, collection. So now what is a data structure? Let's understand that. Okay. So let's start with this. Data structure means, as I discussed, are collections. Collections means nothing but representing, simply speaking, let's have introduction today for all this. Representing group of objects as a single entity. What is that? As a single entity. That's what we call data structure is. Understood now? This is one thing. Next one. Second one, not groups actually, group of objects. And in Python, if you ask me what are the core collections, right? Just a minute, friends. I forget to, what is that? To record. Am I recording? Yeah. So now, yeah, we are recording, no issues. Next one. This is a simple idea, representing group of objects as a single entity. Next one. What's next one? What are the core data structures in Python? Data structures in Python. Let's see this now. Let me just show you. These are all core data structures like Python, sorry, string, and then list, and then what else? Tuple, and then dictionary. Set, of course, set is also important, and then dictionary. We call it as dict actually, dict. So these are the core data structures what we have in Python. Okay. Now what we do today is we'll start with string. Okay, because we are doing recording. If anybody wants to go through that, they'll go through that. It's up to them. Okay. But what we do? Dictionary, DIS. We'll start with string today. What is string here now? This is very important actually, the very core thing. And any language, you cannot expect any project without string data, because majority of the cases, your data will be in the form of most of the data will be in the form of strings. Okay, so then playing around that kind of data is very important, and to do that, having a very strong or solid foundation on strings is going to help all of you friends. So what is string here? I think we had a quick introduction some time back, but today what I would like to do is I would like to have a detailed and in-depth discussion about strings which have a detailed coverage. String means simple, friends. A string is group of characters. Okay, what is that? A string is, simply speaking, group of characters. Generally, in Python, these strings are represented in three ways. So string is nothing but group of characters, simply speaking. That is a string. Right. And we can have strings in different, we can declare strings usually in different ways. And in Python, we declare strings in three different ways. Okay. What is that? You already know this everyone here who is attending should have an idea, because we had a detailed discussion while talking about data types. How to declare strings. This is a quick idea. What is that? We can declare string in single quotes, okay, in double quotes, in triple quotes. And I had very clearly discussed the difference between single quote, double quote, and triple quote. If you want to declare single line strings, okay, if you want to declare single line statements, okay, string statements, or just a string. If you want to declare a string or a single line string statement, if you want to declare string or string single line string statement, we can use either this single quote or double quote. Both are same, don't have big difference. Even if you assign double quotes, internally string converts it to single quotes in the output. So your interpreter converts it to single quotes back again. So this doesn't have any difference. Only usage purpose they created this. That's all. I don't see any big difference. And triple quotes is for what? We can use it for declaring a string, line of string. Okay. So here there's a single line strings, or it can be used for declaring a line of string. Like something, this is test or something, or paragraph. Okay, or you can create a big paragraph or multi-line strings. You can say simply, let me use proper technical word to declare multi-line strings. If you want to declare a paragraph, or if you want to declare a very lengthy this thing article, you can create all that with this triple quotes. This is one thing about triple quotes. We can use it for as a string or line of strings, or we can use it for multi-line to declare multi-line strings. Second thing, this can be also used as comments. Okay, third thing, this can be used as docstring. Okay, in functions. What is docstring? It explains about functionality of it talks about the functionality of that function. Docstring means, let me show you here. Let me just show you. Close this. I'll take one quick example for you to show that built-in functions. Anything is fine. Okay. Anyhow, I'll just create a simple test program to show you that how doc strings are. Okay. Test functions. So see here, use some built-in function, something like max. So you can say max of some 10. Come, I'll do one thing. I'll take small list here, L1, just to show you only the importance of docstring. Okay. 1, 2, 3. I am applying some built-in function here. That built-in is, this is max is actually a generic function. You'll soon get it. See, if I put my cursor on this max function, you can see here, I put a cursor on this max function. You can see this documentation here with single iterable argument returns its biggest item. See, this is nothing but a docstring here. You got it right, friends? This is a docstring. And this is something, a description that is provided in triple quotes as a comment. So that when you provide that as a docstring, then that is visible when you put your cursor on that function, like how I am showing here. Can you see this now? This is a docstring. Now you can clearly see that this docstring here, this description. And this description generally is declared inside triple quotes. You can see some multi-line string is there. You got it right. Such things can be implemented by using triple quotes. Got it right. So that is one more use of triple quotes. Okay. So many people only have few differences. They know that this is a single line string, this is multi-line string, something like that. Or they just used for comments. But some people are not aware about this one. So, but we create doc strings inside functions by using this triple quotes. Got it right, ones? Okay, if you have a multi-line statements, okay, that is one more advantage with the triple quotes. Next, we are done with this. Now, examples. How to create a string now? We know we had already used so many examples like that. Suppose some S1 equal to some any string you can create. You can create a simple string. What is that? This is a test. Okay, simple. This is a simple string. And second one is S1. Again, one more example. Okay. something like apple. This is a string. Okay, this is a simple string. And after that, a line of string. You can see here. These are all examples how we can create with strings. And third one, S1 equal to with this one, triple quotes. 1, 2, 3. The triple quotes can be in complete. We can use double quotes to create this multi-line string, or we can use single quotes. It's up to you again. Okay, and then you can say that this is a test. Okay, and again enter new line for this multi-line string, something like this. So one more. So this is how we can create multiple strings in Python. Right? It's up to you how you should create. It depends on your need and necessity. But this is how we create strings. Until this, we are already good with this. We had already discussed. We are already clear with all this stuff. Okay. But what we don't know is what we don't know about the API. Now, what is that we should understand? Till this, all of you are good, right? Can you please confirm in the chat box, or can you say give a thumbs up? Thumbs up should also work for me. All of you are good till this, right? We had already discussed and you have been implementing all that, right? So can I get some response here? So just share me in the chat box if you are good till this. Next one. What is that next here? What is that? The next topic is understanding API of strings. Okay. What is API? Let me just talk about the API. We try to use as many string functions as possible. API or otherwise I can use this understanding and exploring string class. So here we are going to have very detailed this thing. We try to understand about string class, methods of string class, how to apply them, and also use some useful. We try to implement useful use cases with that, so that definitely you'll get a overall picture about all this. This is fine. First thing, one important information to all of you is I didn't mention this. What is that? Two things. One is string is a class in Python. What is that? It is a built-in class in Python. So what is it? It is a built-in class. By default, it is a built-in class which provides a lot of methods to do operations or manipulations on strings. So this is one thing. Okay. Second thing. What is second thing? Second one is let me explain. And this string is something called immutable. What is it? The strings even in Python are immutable, or string is immutable. Similarly, most of the core data types in Python are immutable. Immutable means, maybe you can ask me. First, understand these 2 points. Okay, we know what is string. String is group of characters we declare with codes. All that is fine. The examples are fine. And how to know the type of string, we know. We'll come back to that again, of course. But point is, these are all new things for us. What is string? It is a built-in, not built-in class in Python. That is okay. Then what else? String is immutable. What do you mean by immutable, friends? We cannot modify it. So immutable means, understand this carefully, friends. Okay. Immutable means what? We cannot modify. And that's called immutability. What is mutability? I think I have, if maybe we had a quick discussion about what is mutable and what is immutable as well. So then next one is what is mutable then? If immutable is something, what is immutable? We cannot modify immutable objects. We cannot change it. I'll show you with examples, nothing to worry about it. Okay, that is fine. Then what is mutable? Opposite to immutable is mutable. What is mutable? Mutable means it is something we can modify. We can modify here, right? So that is what. But what is string here? Mutable is something we can change. Immutable is something we cannot change. But here string is what? String is immutable. Means what? We cannot change a string. I'll show you all that. We cannot change a string or modify a string. That is what we call immutable. So this is fine. Next one, let's just first understand all these important points. Later on, we'll go and check with methods. We'll try to understand methods of string class. Okay, next one. String is a sequential or indexed data structure. What is it? It is a sequential or linear or indexed data structure. Indexed data structure. You got it right. This is one more important point about strings. Got it. So when we say string is linear or indexed, if you declare any string, that string definitely has indexing. And we have two types of indexing in Python. What is that? Now, if it is C, C++ or Java, we just have only forward indexing or positive indexing. But in Python, we have two types of indexing. What is that here? We have forward indexing and backward indexing. Okay, what is that we have in Python for any linear data structure? So if a data structure has indexing, and that indexing can be what is that? It can be a forward or otherwise positive indexing. Okay, positive indexing. And one more is what? Backward. We have both. Both. It's not like we just have any one here. It's not like that. We have both indexing, and another one is backward index. Backward or this is negative indexing. Even though it sounds negative, but this is very helpful. Okay, and that is the flexibility Python is providing. So for any linear data structure in Python, you should understand these things first. Getting a good idea about all these things is going to help us. So with this indexing, what kind of indexing we have in Python? A forward or positive indexing, a backward or negative indexing. I'll show that with examples. We'll have a very clear discussion on this. And then after that, what else, friends? So this is the idea about strings. Okay, so what is that? They are immutable, and then they have indexing. They are linear data structures or indexed data structures. All this is fine. Now the question is, first let's try to declare a simple string here. Okay, I'll do one thing. What is that we do? I'll go to the prompt here. Which one? Python prompt. Open Python prompt to get better understanding about things. Okay, you can use. Otherwise, you can also have, this is hybrid mode. This PyCharm has hybrid mode. What you can do is you can open console here. Somewhere you can find Python console. That console also has this prompt. Actually, you can use that. So we don't have any issue with that. Okay. So what you can do is just scroll it up. Now declare a simple string here. Okay, string something like I am using a simple fruit here. Okay, apple. Enter. So when you declare a string, suppose this is our simple string here, s1 equal to apple. Okay, now after that, what else? You know, right? By looking at the example from all this discussion, this has indexing. Okay, that is fine. Next question is, how do you check type here? How do you check type of okay, a string? How do you do that? A type of a data type. For that, we use type function. Most of you know that, and we applied it some time back as well. So to understand, I declare a string. What is the implicit data type assigned to this? We already know that. So just for quick checking, I'm showing you. So use type function. And if you see, it is a string str, string class. Actually, if you see the data type, implicit data type is a string class. Okay, we declare a string and we try to check the type of that string, and it is showing that as a string. This is fine. Now, what else should we see? One more thing. To the same S1, I want to know what is the address of S1. So ID equal to in this one, sorry, ID of S1, enter. You know, right? Every string is associated with some address. See here, friends. Every string is associated with some address, right? And it has some data type, not some data type. If it is a strings, it will be a string data type. So every value, point is every value is associated with one data type and a address. So I'm trying to print the address of string here, just to make you understand the concept of immutability. Right now, what you do is take S1 and then assign a new string to this. Instead of apple, you assign banana. Okay, then press enter. Now type you don't need to check because these are all strings. Obviously, the data type will be string only. No problem with that. Okay, we don't have any issue with that. But the just check ID of S1. Let's see if it returns same address or a different address. See, when I try to assign a new value to that old variable S1, what happened now? It is not. See, the address is changing here. That itself shows this value is not updated in the same object. When you try to assign a new object is created. You can see here what's happening here. It try to create a new object. If you look at this output and all this, you can clearly understand that difference. From this, you can easily understand the concept of immutability. If you try to modify a string, what happens? It doesn't replace that string. It doesn't make change to that existing object. When you try to assign a new value, what it does to the old variable, it try to create a new object for that. Every time you try to modify a string, it creates a new object. And that is called new immutability. Immutability means the old object is not modified, but when you try to make a change to that string, every time you make a change, a new object is created. Such scenario is called immutability. Anyhow, let me explain that with a paint, okay, so that you get a clear, bigger picture. So let me show you how it is happening in memory. Suppose this is your string, friends. First one, S1 equal to, you put apple. This must give you a very clear idea about what is immutability. So that from hereafter, you don't need to have any confusion about immutability. Okay, immutability means something cannot be modified, but how that happens in memory, right? Let us see that. Now I assigned apple. What happens in memory? In memory, it creates an object for apple. Okay, and then what happens? This apple, whatever you assign to that S1, that apple is put into an object, this apple, and it has some address as well. Some assume that our address is 100, and then our variable is S1, and then in that S1, this address is assigned. What is happening now when you create apple? An object is created for apple and that value is placed into that. Also, an address is assigned to that object. And this address is simply copied to which one? S1 here. Now, S1 is a reference here. Simply speaking, it is a reference which holds address of this object. You got it right? Till this is fine, right? To all of you? Right. Next one. After this, what? Suppose as long as you don't do any change, this S1 will be pointing to the same apple. All of a sudden, what happened now? You modify S1. So what you did now? You assigned S1 equal to banana. What happens now? Our generally what we think, this banana will be replaced in this object. Instead of apple, what we might think is this apple is replaced with banana. But in reality, if that object is immutable, this object is not touched at all. This is not going to change at all. When you assign a new value, then what your interpreter does is it creates a new value again. First, it creates a new object for banana. See this. Okay. And then what it does, it try to put that banana into that new object. It put that new object into this new object, assigns a new address, some 200. Okay. Here I'm just giving you giving a random address. Okay. But in memory, it might be different. So just for our discussion purpose, I'm putting 200. Now what happens when you say S1 equal to banana, the new object is created because you are changing that string here. When you make a change to the string, every time you make a change, a new object is created. It doesn't touch this old object. That is intact. It is kept as is. Now a new object is created. What your interpreter do? It will simply now it copies the address of this new object to S1. What it does? Instead of this 100 in place of in S1, what it put? It will replace this address with 200. Now reference to this object is removed. This object is still same, Apple object only, nothing changed. But what is that? Apple object lost this external reference. Now S1 is pointing to a new reference. Got it right? New object. So this is what happens in memory. What happens when you declare a string object, that object cannot be modified. If you try to make a change to that string, what happens? This is what happens. Every time you make a change, a new object is created and the address of new object is replaced in that reference variable. And that this link to old object is removed. And this object becomes garbage collectible object. So this is immutability. Got it right? So if you look at this whole discussion, or if you observe this whole discussion, the question is, I'll just ask a quick question. Please answer in the chat box. The question is what? Is this object getting modified here? When we try to make a change to that string here, is that new string is replacing this one? Is it changing the existing one? No, the change what we make is not impacting anywhere on this object. What is that? A new object is created that is assigned to the address of that new object is assigned to reference. And this scenario is called immutability. If it is mutability, we don't have this new, you don't need this new object. What happens if you try to modify that object gets replaced here. I am talking about mutability if it is mutable, but this doesn't apply to string, because not only string, this is doesn't apply to any immutable object, and the behavior of any immutable object is this. You got it right? This is the idea, friends. Understood now? So that's all, friends. This is idea about what is what is string, and what is immutability of a string. All of you are clear on this, or any doubt or anything else on this? Can I get an yes from all of you? Please answer in the chat box, or at least try to convey your understanding. Are you good with this? Yes or no? I'm not seeing any response from anyone. Fine. Okay. This is the idea of what is it, friends? Immutable. Next one. How to check data type is done. Okay, we can use type function. This is discussed. Next one, what else we had discussed? Immutability. What is immutability? How it right? How strings are managed internally in memory. We had discussed that when you try to modify a string, how they are internally managed. That we had discussed. What else after this, friends? We have to understand about indexing of string. Okay, so let us take. Let me show you how. Next topic is how indexing is applied to strings in Python. Otherwise, understanding, I'll just name this like this. Understanding what, friends? String indexing. You got it right? String index. Okay. So let's take it. This Apple. If you want, you can take Apple, or little bit bigger one also. No problem. Okay. So you take this Apple as example. No problem. So here, this has indexing here, and the indexing of any string starts with 0. Okay, even for Apple also, it starts with 0. So this is, I'm showing you one. First thing is this is the example. So what is that I'm showing? I'm showing you the positive indexing. 0. First one is 0. Second one is 1. Second index. Third one second index, fourth one, third index, and fourth index. This is how the indexing would be for the string. It starts with 0, ends with that size -1. Okay, similarly, there will be a negative indexing. Negative indexing starts with, suppose if your length is 5, it starts with -5. And then after that, it will be, let me put some spaces. Even space is also a value, a character. But here for our understanding, I'm just giving you, I'm just adding the space, but we don't have any spaces here. Just for showing indexing, I'm just having some space here. So something like this, just to have better understanding. Okay, this is how indexing is applied for Apple, and this indexing is automatic. This is by default provided by the interpreter itself. Okay, next one, negative indexing. This is -5, or else we can start here. The rightmost one will be -1, and after that next one will be -2, like this, and it goes till -n. Okay, again this is -3. Okay, and once you understand indexing for one data structure, it would be same for almost list, tuple, okay, or any other linear data structure in Python. Okay, and then -4, and then what else? And then -5. So this is the indexing of what, friends? This is how indexing is provided in Python, both positive and negative indexing. You can see here. You got it right there. This is how indexing is applied in Python. Got it now. So now what do we do? Once we get a clarity here, like, how this indexing is declared and how it is for, how it looks for positive indexing, how it is for negative indexing. Once you get this clarity, right? What is that we should do now? How to extract. Next topic is how to extract element by element. How to extract otherwise a character from. Suppose I want to get a character from a string, then how do you do that? Right? Is this is clear, right? The indexing part is clear to everyone, right? So I'm just concluding or summarizing. Generally, indexing is provided from 0 to n-1 or size -1 if it is positive indexing. And negative indexing is, it starts from with -5 and ends with -1. Okay, that's it, friends. -n to -1. So this is how indexing is provided. Here I say -5 because depends on the length of string. Suppose it is a bigger one, we can say -n here, -n to -1. Here 0 to size -1. If it is a dynamic string, okay. This is how indexing is provided. Next one, how to extract a character from a string. How do you do that? How to extract a character from a string. This is the next one. For that, to extract any character, this concept, whatever we are discussing, is equally applied for other data structures like list or tuple or any other linear data structure. Just remember this, okay? Understand this clearly, carefully, so that once you get a good picture on this, you can easily play with other data structures, linear data structures. So now, simple. To extract any character or to do any operation on string, we use indexing. What is that? To extract, okay, a value, sorry, I think extract a value from a string. What is that we do? Or a character from a string. We use what? Index. Not indexing, index. Right? So let me show you an example here. So suppose I want to extract a value from 0th index. This one. Okay, if I should extract a value from 0, then I can extract it like this, something like S1 of, suppose we are assigning it to S1 here. I want to get the first character. If I want first character, just simply use that index S1 of 0. This returns A. Okay. Even this one character is also a string in Python. Everything is string. Would like in C, C++, we don't have single character and string something, double character, something like that. Here, even this is also a string. Now, using this index here, we try to extract a value from a string here. Now I want to get something from 0th index, just pass that. Else there is another way here. S1 of -5. Even in this case, I can get the first value from the string. A first instance, something that is there in 0 or -5. How to get a first character? This is how. -5 because the length of string is just 5 characters. So we have to use -5. If it is 10 characters, then I should say -10. If it is 20, -30. If you are using negative index to extract a character from a string, first character from a string. Okay, this returns A again. So this is a quick idea. You can see the advantage is this in Python. You can use either positive index or negative index if you want to extract something from your linear data structure. It can be a string or list or tuple, whatever it is. Okay, or this is example 2. Understood, right? Fine. There is so much about all this. Whatever we are doing, these are all very much needed when you are working in your projects. Maybe you might think that these are very basic examples, but these are very much needed. Trust me. Okay, next one. What else we need? Let's test this quickly. How to extract a value? Go to the prompt here. So just you have already declared a string here. What is that? Just say S1 of 0. So I'm trying to extract first character from the string. So you already, by now, you should have a clear idea how to extract that value from the string here. Okay. S1 of 0, enter. So what is that I got? I got B. Just a minute, friends. Okay. I changed the value here, right? So okay, no problem. I can reassign to Apple because we had discussed, we had done our discussion with Apple. So S1 of 0, this should give us A. Again, S1 of -5, because the length of apple is 5. You can now you can see even you can use -5 to get that first character from the string apple. Or you can use 0th index to get first character from the string. Right? This is fine. Right. But this is not done. There is something very important which we use rigorously, extensively, right? A lot of times on strings. That is called slicing. Okay, even we use it in our day-to-day development. Like how we use is we have certain dates actually. I'll give a scenario so that you might use this to explain somewhere in the interview as well how you are applying slicing. If such scenario comes in the interview, we have certain dates, okay, in our project. I'm not talking about anything about my project, but only I'm trying to give you an idea. So that date will be not just like suppose today's date is something like 14. Okay, so 14, okay, -09 -24 2024, something like this. It also has some additional things like backup. They add some additional stuff like this, or so they put something like this, friends. We generally these development teams, because we are DevOps team, right? So and we manage different infrastructure, and one such infrastructure is database. So here, what these dev teams do is, because we deal with many dev teams, these dev teams just create their dates like this with some kind of additional this thing if they want to keep that data as a backup and they don't want to get it deleted. Okay, similarly, some people give some other things, like instead of that they put their names to that this thing. What they put? They put some names like some Manoram, okay, something like this, or something like okay, like Pradeep, okay, underscore some Pradeep, something like this. They put some names like this. They add, because assuming that this is created by Manoram, this is created by Pradeep, but these are all backups actually. If it is actually genuine data, these extinctions are not added. Additional this thing is not added to the string. Now, when we are trying to delete all this kind of even backups, all this stuff from that particular folder, what is that we do? We need to apply slicing. What is that? We apply a slicing. I am giving you a real scenario how we can use slicing. But tomorrow I'll talk very detailed about slicing, how slicing works, all that. What slicing does is it will breakdown. It just divide this string into slices. So what should be that slice, and where you want to break down the string, and and which part of slicing is needed. All that you can provide with some indexing. Okay. Now, anyhow, I'll give a detailed analysis. If you try to listen to the topic, definitely after that you will be able to apply it immediately on any kind of application. But I'm giving you what is slicing here. So another important scenario, once you know just this basic understanding, how to get some character from a string, another important, how to get a part of a string or a substring or a slice of a string. Then slicing is one of the very common thing which we apply in day-to-day development. Okay, slicing gives you, what is that? The part of a string. Okay, that might be starting string, ending string, or in the middle string, or whatever it is. There is so many things, so many scenarios with slicing. I'll just try to give you as many, provide you as many scenarios as possible. Now here I want to break down this. Okay, what I want to do, I want to break down this. If I want to break down this, what is that I can apply? Simple, easiest thing is slicing. Of course, there are different approaches. And one simple approach, and the very useful, simple and best approach is slicing in day-to-day development. What slicing does, we remove our date till this and just exclude this. And that we pass it to some kind of this thing. Okay, so we will try to put it somewhere so that this date gets deleted completely. And this extinctions stops us from deleting these folders with these dates. These dates have some data inside that, just giving you an idea. If this should get deleted, what is that we should do? We have to just apply a slice and just get till this. How many characters? Generally 10 characters will be there in the date. They try to extract this 10 and exclude this so that this date will become deletable date. Or what is that? We can completely remove it. And this extinction stop us. So to handle these kind of scenarios, what is that we do? We apply a slicing. And this example, what I explained as of now, this helps you. Even in interview also, you can confidently explain this date scenario to anyone. Definitely, they understand that you are working in some project. So tomorrow I'll talk about slicing. I don't want to extend time today. Already we are done with this. Got it right there. So this is the simple idea. Simple idea about what is string and whatever the important features of string or characteristics of string. And then what else? Also, we had discussed about immutability and all that, and then importance of extracting a string using this index. And then we just had introduction to slicing. We didn't have to discuss. Tomorrow I'll provide you syntax, and we try to work with at least some 10 or 20 examples on slicing so that you become hands-on. Definitely in the class itself, you can play with that slicing. Okay. So that is the idea. Got it right. I gave you only the how we do slicing, importance of slicing. Why should we use slicing? We'll talk about other things like, important aspects of slicing in tomorrow's session. Shall we stop here? Not tomorrow. We'll catch up again on Monday. I'm fine with tomorrow also, but let's give a break for tomorrow. All of you are good here. Mahesh, is that Martha Mahesh, right? Or okay, then it's fine. I was just wondering. Okay, okay, friends. Shall we catch up on Monday again? So I hope you are good till this. If you have any questions, you can stay back and you can ask me like yesterday. Else you can. Okay. Also, we'll catch up on Monday. Any questions? Okay, friends. Then thank you. We'll meet on Monday.